what's up, Brian? What's up, Jimmy? What's up, Dave? How's Electronics 2 going? It's going well so far. How's Electronics 1 going? You know you're gonna be here soon, so what's going on? I know, but those exams are going crazy, bro. Oh my goodness.
I feel you, bro. I feel you, man.
But it's all right so far, man. But anyway, why is Jimmy so sad? When it gets dark outside where he is, he gets really sad. Well, I guess we gotta brighten up his day then. You know what? Oh my goodness. That's actually a great idea. I think he'll actually get really excited if I do that. Wait, what do you have in mind? Wait, just give me 1 second.
Approximately 10 hours later.
Okay, I'm back. Oh
Mm-hmm.
man.
1 second, huh?
Took a while. I think I found a way to make Jimmy happy. Watch this. Wait, how'd you do that? Arduino and processing. Arduino and processing? Oh, I forgot you're not in electronics 2 yet. Okay, just let me explain.
Okay, so before we get into the Arduino and processing, it's only fair I go into the circuitry involved. Here we have the ground and power source connected straight from the Arduino, and this allows for a closed loop. To get into the components, we have the photoresistor over here that senses the light and goes straight into the analog 10-bit analog input, and then we have the servo motors here that are connected because of these pins. One of the pins connects to ground, and then this one is the power source, and this connects to the digital PWM input that allows for the servo motor movement. The whole idea of this project is that as this photoresistor senses more light, this will increase the rate of claps of the arm. With less light, it would decrease the rate of claps. With the higher the rate of claps, the more Jimmy smiles, and the lower the rate of claps, the more he frowns. So in Arduino, it can generally take in an input and give out an output, and I define those over here. Then for the void setup, we send the light information straight to the processing code, and then we scale the 1024 steps of information to 100. For the motor itself, when the light sensor information was less than 16, the motor moved from 0 to 90 degrees with a delay of 1000, which was generally slow. But as we increased the light sensitivity, it got faster with a delay being much smaller, indicating the servo movement was getting taking less time. For the actual nuts and bolts of the servo motor, we define each degree with a high and low because of the duty cycle, which is defined as the time high over time low, or the time high over a given period. And we needed to do this because of the pulse width modulation, which manipulates the duty cycle. As we manipulate this duty cycle, we're able to go in a clockwise and counterclockwise direction, allowing for the clapping motion. So here we have processing, which is really for the visuals. Here we define the dimensions of the processing screen and also the input from our Arduino. We then look at the information being sent from the light sensor here, and we send that information to be scaled down to meet the dimensions of the processing system. Then we scale it down to 100 for the face of Jimmy, where if A is greater than 16, the background will increase in brightness, but if A is great or less than 16, it'll decrease and go darker. And then I just define Jimmy's face here. Continue on with Jimmy's smile. If A is greater than 16, his smile will increase, and also the text for happy will appear. But if A is less than 16, Jimmy's frown will increase with a text for sad appearing.
Are you understanding so far? Yeah, that actually makes sense. Okay, so this is what the whole project looks like altogether.